As a continuation of the previous discussion, which was about the gradient and tangent to a curve, as a reminder, to get the gradient, we need the value of the rise and the run. We divide the rise and the run to get the gradient. The value of the rise could be either positive or negative, but the value of the run is always positive. We also need to remember that for the gradient of the curve, we need to draw a tangent at this point. Thus, the gradient of the tangent is the same as the gradient of the curve at the point. Now we will return to the book. We have a very important interactivity on page 198, which explains how, regardless of the curve, we can deduce the gradient of the curve at this point by drawing the tangent. Let's take this interactivity, which gives an example about parabolic function with equation y equals x squared plus x minus 3. In order for us to draw this parabola, we need to specify particular points. If we press on any point, we can observe that the tangent changes. Thus, a new tangent is deduced for each point. We said that the tangent is a straight line, which means that the angles between the curve and the line are almost equal. Let's take this straight line for example. We need to determine the gradient of the curve at this point. The coordinates at this point are 2 and 3. First, we have to click on the Show Rise and Run icon, which is on the left side of this page. A right triangle will appear on the graph, and we can see the straight line, which is the tangent, as the hypotenuse. This is the run, and this is the rise. As we can see, the rise is going upwards. We press on Show the Gradient icon in order to find the value of the run. Thus, for the run, we have to count the units 1, 2, 3, and 4. So the unit equals 4 units. However, for the rise, every small square is 1 unit. So we have 20 units, and since we move upward, so the rise is plus 20. Therefore, the gradient is equal to the rise over the run. Thus, 20 over 4 is equal to plus 5. So this is the first part where the straight line is going upwards. The rise will be positive and it will be divided by the run. However, if we try a different point and the straight line is going downwards, the run will always be positive, which is plus 2. However, for the rise, it will be a negative value because the straight line is going downwards, which is minus 14. Therefore, the gradient is equal to minus 14 divided by 2, which is minus 7. So this interactivity clarifies what is meant by gradient of a curve at a specific point, how to find the values and the sign of the rise and the run relative to the direction of a straight line. So now you are able to practice at any point in order to find the values of the run, the rise, and the gradient. You may hide the gradient to find the answer by yourself, and you can hide the rise and the run to find the specific units. Later on, we will be using the same process in order to draw the tangent and to determine the rise and the run by drawing the right triangle. Then we read the values and divide the rise by the run in order to get the gradient of the curve at a particular point.